Alright guys, this is Ashwin here. In this video, we are going to see how to build a face detection module. So this is our object detection project. We are going to use pytorch as a backend. I am having an NVIDIA device, so I can able to use it with the GPU. And I'm going to use detecto. If you didn't see about detecto, means you can able to check the previous video. So we are going to use custom object detection. I have a few images for the dataset and I'm going to label the image for custom annotation, and after that I'm going to train it with the model and detect the mask in our face. So that is the objective of this problem. So for the installation, just uncomment these lines and run it. It will install the necessary modules, and apart from that we are going to use some basic modules. Let's import some of the modules here. So from fill import image, this is to read the image, and import OS, this is to do some modification for the existing images, and for visualization we have to use matplotlib. So import matplotlib dot pyplot as plot, and after that we have to import detecto module. From detecto import core utils and visualize. Okay, these are the modules we need for this project. Let's run this, and we have imported all the modules. Now for formatting the images, I have images downloaded from Google. It has different resolutions and of different quality. Let's see the images. So as you can able to see, these are the images I have downloaded, and this is the test image. I'm going to test it for prediction. And all of these images, let's open some of this. So this is somewhat a good image. Here the quality is dull, here the quality is decent, and all the images are good, and it's all in different resolutions. As you can able to see, it's in a different resolution. We have to format it in the same resolution to feed into our model. So these are the images I have. If you want to train it for a perfect model, means you need to have more images, so that you can able to download it from anywhere, and you can also get it from some dataset. So we have to format these images. Let's do that here. I will create a function format images. I will pass the directory there. Okay, this is a keyword, so I will pass it as directory comma size. So these are the two things we are going to pass. Now we have to iterate the images in that particular directory. So for I comma image in enumerate, we have to use the os dot list directory, specify the directory name, directory, and it will go through all the images in this particular directory. So for each image, I will say im equals image dot open this image file, but we have to use directory in front of this, directory plus image. So in this particular directory, it will open this image, and after opening the image we have to resize it. So im resize equals im dot resize. We have to pass the size and some default parameter called image dot anti-alias, and after that I'm going to save this image in the folder. So im resize dot save, we have to save it inside the folder. So the directory directory plus str of I. Each image currently have different names. I am just changing the name by using this index. Using enumeration, I'm just having the numbers from 0 to the length of the images. So it will be 0 here, and I'm just converting into a string. And we will just add .jpg. So this is the format I'm going to save. And after that, we have to remove the existing image. So that is os.remove directory plus image. So I'm just deleting this image. So when you run this code, means it will delete the previous image, and we will have the resized image in the directory with changed names, that is from 0 to some 15, I guess. Let's run this code. Let's call the function format images, directory is images slash comma size. I'm going to set it as 800 comma 600. Let's run this. Now everything is done. Let's check the directory. So as you can able to see, before it was a different image, but now everything is same image. We will just delete this particular image because it's in the test directory. We are going to test that, and every image is of equal size now. You can able to see everything is in some rectangles shape. You can also check the resolution, file information 800 cross 600. So that's the resolution we have. Totally we have 16 images. So that's good. Now we have to do the labeling on the mask. So this is done. I will add a new title. Label the images. Now to do this, you have to install label image module. Just run this code, pip3 install label img. Just run this thing, it will install the module, and after that, if you want to open this module, have the exclamatory mark, and after that label image, run this. It will open a GUI for us in order for us to label the images. Yeah, this is the GUI. We have to open the image directory. So this is the directory. I'm having all my images. Select the folder, and this is the marking I have already done. So if you are doing the image labeling, means just enable this auto save mode, or else it will keep on asking for you to save the label. And we are going to have only single class, that is mask. If there is mask, means it will show. So enable this single class mode, and this is the marking, and I have made it as a mask. Next image, all the images I have labeled it. So this is, I have done it before. If you want to do it as a new, means let's delete this one and have a mask. Click on this create rectangle and mark this mask, and you have to label it as mask. Press OK, and we will have this labeled annotation. Now after that, it will automatically save the annotations as an XML file. So here change the save directory. So I'm going to change it to select the same directory as you have the images. Select this folder, and now you can able to see we don't have any annotation, so we have to create the annotation for each and every images like this. and it is automatically marked it as mask, and after that go to the next image, and like this you have to create annotation for all the images. So you can able to download the images with the annotation in the GitHub repo. I will upload all the images for the training. I will quickly do the annotation, and after that we will see. So I have done the annotation. As you can able to see, all the images have annotation. Now we are going to use this for the training dataset. Just close this label image and we can able to use it. If you go into the directory, we will have all the XML files with the coordinates of the mask. Let's open it with Notepad. You can able to see the annotation images, the file name, the label, and the size of the image, and this is the box I have mentioned, and the label name. Like this we will have labels for all the images. If you have multiple images, means we have multiple objects. Like this we have done it for the training data, and this is the testing data. I have only one image. So here for the test data I just have only one image. Now let's go into the code. We have done the labeling part. So this is annotate the images. That's done, and after that we will do the training. Before that we have to load the data set. So let's load it now. Dataset equals core.dataset. The backend functions are using pytorch modules, so it will be pretty easy. And I am going to specify the training directory, that is the images, and after that we have to load the module. That will be model equals core.model. So this will load the default module. We have to specify the class name, that is mask. That is the label we have annotated so far. And if you have the XML files in a separate folder, means mention the folder separately using another argument. That is first we have to specify the labels folder, and after that we will specify the images folder, but the image name should match the labels name also. So be sure to remember that. I'm just having all the things in the same folder, so we don't have to worry about that. Now model dot fit, pass the dataset. It will train it for 10 epochs. So let's run this. And now it's starting the epoch. We have total of 16 training images, so it's just training on that. If you have more images, means the training will go longer. And we can also pass other parameters like the number of epochs, learning rate. Maybe I will just show it after adding the augmentations and doing some customizations in the model. So here I think everything is done. If you have more number of classes, means just have a comma and specify the class name, like class 2 or no mask. Like that you can able to specify if you have multiple classes. So that's that. Yeah, it will take some time for the training, because object detection is like a high computation module. It will take some time for this, but if you do this for image classification, means it's just ran so quickly, because that is different. So in the meantime, for testing the model, we will do the coding. So for testing the model, we will have to load the image. Image equals utils dot read image, read underscore image. So it's in the test directory, and the image name is test.jpg. And after that we have to do the predictions. So predictions equals model dot predict top, pass the image. it will have the predictions, and these prediction will have separate labels, boxes and scores that we have seen in the previous video. Maybe let's have it like that itself. Labels, boxes, comma, scores. Now after that we can able to print the labels, and we will print the score itself. We don't need the boxes because we are going to visualize that, and after that we are going to visualize the predicted image. Visualize dot show labeled image, comma, boxes and labels. So that's done. We have done the training. If you have some validation data set, means you can able to pass the validation data set over there. Let's run this. See, we have a rectangle box over the mask, and we have identified the class, and that is mask. Like this we can able to do the object detection, and you can able to see the score. This is having 98% confidence. That's how we have to do the mask detection. And you can also do it with various test images, like with multiple persons and with blurred image. If you have decent predictions, means you can just leave it as it is, or else you have to do some more approach like this augmentations. So this is as simple as possible. I just done the object detection. Usually it will be a tedious process with lots of code, but using this module it is pretty easy. I guess for beginners it will be very useful. Now let's do the customizations for the model. If you are going to compete in some hackathons or Kaggle, means you have to do some augmentations or some advanced techniques. For that, let's do that. So you have to import another module, that is from torch vision, import transform. So this is, I'm going to use it for augmentation. So augmentations equals transform dot compose. So inside this you can able to have all the transformations. So add it one by one. So transform dot to fill image, think it didn't run, to fill image. Like this you have to add everything. You can able to see the documentation and add it quickly or copy and paste it, whichever you want. I will do a horizontal flip. So transforms dot random horizontal flip, that will be 0.5, and after that transforms dot to tensor, and we have to normalize the images, that is a basic. So utils dot normalize transform. Think that is enough for our augmentations. You can able to add more number of augmentations if you want. If you just say transform dot, the function has so many augmentations. See random resized crop, random rotation, random crop, random choice, random erasing. Like that you can able to use it various augmentations based on the project. For now we will just use it this one. Again we have to use the dataset. So dataset equals core dot dataset, pass the images folder, and transform. This is transform equals augmentations, that is we have initialized here. I'm just passing this to the argument, and we will be having some kind of data loaders in most of the object detection or image classification, right? Similarly we are going to have a data loader here. I will call it as loader equals core dot data loader, pass the data set we have created, and we can specify the batch size equals 2, and we can also use shuffle equals true. So these are some basic arguments. You can also add it more if you want. And after that, we have to initialize the model equals core dot model, and again we have to specify the class name, that is mask. Okay, let's run this. Okay, I think I made some mistake. This is capital P. Run this. Yes, everything is done properly. If you have a higher GPU, means you can able to increase the batch size. If you want to go in a safe side, means for object detection 2 is a minimum, that is the best, or else you can go for 4 if you have a smaller image size. Now let's train the model. We are also going to visualize the losses. So losses equals model dot fit. So this is the training function. Have the loader. This is for training. Even for validation, you can also create a separate loader with the validation folder, but I don't have any, so I just leave it as it is. And I will pass other arguments, that is epochs is 10, and learning rate is 0.001, and LR step size, that will be 5, and verbose equals true. If you set it as false, means these kind of loading screens won't be there. I think I have closed it, so these loading screens won't be there. So that's it, and after that we have to plot the losses. So plot dot plot losses, and finally plot dot show. Here we can able to visualize the losses. Run this. Again, it's iterating over the data set. It will take some time. And similarly, for testing the model, we are going to use this. Because of using one image, I think it's pretty much it. Maybe I will add another image from the training data itself to check whether it is working or not for multiple images. Let's leave the training for now. So I have trained the data. I didn't do the plotting. Maybe we'll just comment these 2 lines, or even delete it. We don't need that. So I think it didn't return anything to this losses variable. Maybe I have to check that. But usually it will return some history for accuracy if you do have a validation data. I think you need to have the validation data in order to get these losses. Currently it is none. So if you are passing anything, means, and after that you can able to do the plotting of losses and accuracy. So I have trained it for 10 epochs. Now let's run this. And again we have detected the mask with the 87% confidence score. Before that we had like 98. So it's okay for us because we have done some augmentations. So it will do some random flips, and because of that we may lose some confidence. Let's do the same for another image. That's test 2. Let's run this. Now you can able to see it has detected one mask, but it didn't detect this one. It's having a high confidence, that is around 92. Let's remove this top. Run this, and now it's showing so many scores. Like I think this top 2 is enough. If you just filter out this top 2 and have the mask, means it will have these 2 mask. Because of not using the top, we can able to see so many miscalculations are there, and you can also see the scores that is so much less. So just have the top scores that is more than 80%, just have it and label the images. And apart from that, you can just leave it behind. If you use predict top means, it will have one image that is have the highest confidence score. So if you want to do multiple prediction means, just filter out some of the boxes here and try to label these images. That's how you can able to do. I think so that's it for face mask detection. We didn't do that much training and we don't have that much data to train the model to a perfect state. But for the initial stage, in order to go for a simple face detection model, this is perfectly fine, and we have done it pretty much good for this clear images and all. You just have to do some filtration and do it for other images also, and it's clearly showing the score. Based on the score itself, you can able to filter out the original labels and leave the rest, that is low confidence scores. And that's it, guys. You can able to see we didn't do that much. This is for augmentations, and I added so many metrics if you want to do some customizations. And apart from that, we already done the training with around 5 lines of code. We didn't do that much manual work here apart from this labeling the annotations. For beginners, this module is pretty good, and you can able to use it for any other object detection task. This is one of the important application in data science. And that's it, guys. If you have any other module similar to this means, leave a comment below. I will try to make a video on that. Apart from that, if you like this video, hit the like button and don't forget to subscribe the channel and share the video to your friends if this is helpful. See you guys in the next video.